And this simple neural network with like a one input layer, one hidden layer, and one output layer. The input layer has two nodes, the hidden layer has two nodes. Then we can represent the ages as like W standing for weight and the first index being the destination. So this goes to zeros of the hidden layer and coming from the zeros of the input layer, so it's W00. And this one goes to the zero of the hidden layer and coming from the index 1 of the input layer, so it's W01. And this node going from 0 of the input layer and going to 1 of the hidden layer, so it's W10. And this one goes from 0, 1 of the input layer and going to one of like the hidden layer, so it's W11. So first index being destination, the second index being the source there. So if we represent the weights in this way, then we can using matrix multiplication to represent the whole forward propagation process. So basically we can construct a matrix like B being a constant, being the constant offset of this hidden layer node. So let's call this the offset B1 and B0 and B1. Then if we returning this way, like all the all the nodes going to zeros of the hidden layer B0, W00, W01, and this is going to the second node B1, W10, W11. So returning like a matrix formation and then multiply by a vertical vector. So adding 1 to these two input layers 0 and 1, then the linear combination of 0, 1 adding this offset would be A1 and A0 and A1 for these two numbers after the linear combination. And then usually we have an activation function at each node there. So let's say it's just a value in this case, then the value can be applied to this A0 and A1 and then become the output value of these two hidden layer. And then you can continue to go to the output layer or more layers if they're like there are more hidden layer in the neural network.